Hello everyone, welcome to Power Electrics. Today we'll discuss about some important DC generator previous year question. So let us start the discussion. Question number one: the EMF induced in the DC generator armature winding is option A AC, option B DC, option C both of the above, and option D none of the above. The generated EMF from the armature winding is always DC. Is always AC. The output of the DC generator is DC, but the output of armature is always AC. So the correct answer is option A. Next. Question number 2. A DC generator used for AC welding should have option A rising characteristics, option B dropping characteristics, option C straight characteristics, and option D none of the above. In AC welding, more currents are required with less voltage. Due to that, the characteristics becomes drooping. So the correct answer is option B. Next. Question number 3. The function of the dash is to facilitate collection of current from the armature conductors. Option A yoke, option B commutator, option C pole, and option D brush. The function of a dash is to facilitate the collection of a current from the armature conductor. The only device is commutator, which can collect the current from the armature conductor. Then what is the purpose of a carbon brush or brush? The function of a brush is to collect the current from the commutator. The collection of a current, this is the important term. Collection of a current from the armature conductor. If this type of question is given, then you can write commutator is the correct answer. But if the question changes to collection of a current from the commutator, in that time you will answer the question as a brush. In that time the correct answer will be brush. Bus. Okay. Next. Question number 4. In a DC series generator, the terminal voltage with increase in load will option A decrease, option B increase gradually and then stay at rated voltage, option C increase to rated voltage and then may decrease, option D remain nearly constant. In a DC series generator, the terminal voltage will increase. If the terminal voltage will increase, terminal voltage increase with load, then due to the load will increase, then more load current will flow, and the due to it is a series generator, the voltage drop will occur in series field winding. Due to that, first case, increase to rated voltage, the voltage will increase to rated voltage, then it may decrease. Why it may decrease? Due to series field winding presence, some voltage drop will occur. The correct answer is option C. Next. Question number 5. A DC generator can be termed as option A rotating amplifier, option B prime mover, option C power pump, and option D none of these. A DC generator can be termed as a rotating amplifier. Why it is called amplifier? Because it will increase something. That means it is increase the voltage level. Due to it is called amplifier, but it is rotating. Due to it is a rotating device, that's why it is called rotating and amplifier. Option A is correct. Next. Question number 6. A shunt generator running at 1000 rpm generates EMF of 100 volt. If the speed increases to 1200 rpm, the generated EMF is dash. Option A 140 volt, option B 120 volt, option C 240 volt, and option D 360 volt. First of all, whatever the data will given, you have to write the data. Speed is 1000 rpm, EMF is 100 volt. If the speed increases to 1200 rpm, that means this is the N2. Speed N2 is 1200 rpm, speed N1 is 1000 rpm, and EMF E1 equal to 100 volt. So what is the generated voltage? Generated EMF E2. Now go to solution. E directly proportional to N. E directly proportional EMF directly proportional to speed. And EMF is E1 upon E2 equal to N1 upon N2. So E1 is 100 is given, 100 volt is given, E2 is not given, N1 and N2 are given, 1000 upon 1200. Now we need E2, so E2 move to the E2 move to the right hand side, so we get E2 equal to 100 multiplied into this 1000 upon 1200 move to the left hand side. Now E2 equal to 100 multiplied into 1200 upon 1000. 1 minute. Perfect. Now E2 equal to 100 into 1200 divided by 1000. Now it will be cancelled, 0 will be cancelled, and you will get 120 volt. E2 equal to 120 volt. You will get 120 volt EMF. So this is the correct answer. Next, question number 7. The type of generator used for arc welding purpose is a dash generator. Option A series, option B bond, option C cumulatively compounded, and option D differentially compounded. In cumulatively compounded, you will get more voltages and less current. But in the case of differentially compounded, you will get more current as compared to voltage. So differentially compounded is best suited for welding purposes, arc welding purposes. The correct answer is option D. Next, question number 8. A regulation curve of DC generator is also called dash characteristics. Option A armature characteristic, option B no load characteristics, option C load characteristics, and option D external characteristics. Regulation curve is also known as armature characteristics. Option A is correct. Next, question number 9. A 4-pole generator having lap-wound armature winding has 51 slots. Each slot contains 20 conductors. I am marking 51 slots, 20 conductors given, number of pole that is 4. Here this is the lap wound. What will be the voltage generated? What will be the voltage generated in the machine when driven at 1500 rpm? Assuming the flux per pole is 7.0 milliweber, then what will be the which one of the following option is correct? Option A 178.5 volt, option B 138.5 volt, option C 89.25 volt, and option D 208.5 volt. The correct answer is option A 178.5 volt. Now next we will discuss about this question, how to solve this question in simple way. The data is given number of pole equal to 4, and due to lap, this is a lap wound, number of pole equal to number of parallel path. Due to that, P equal to 4 equal to A. Then number of slots is given, number of conductor per slots are given. But number of conductor, number of armature conductor is not given. Due to that, we will calculate number of armature conductor Z, and Z equal to 51 multiplied into 20. 51 is the slots and 20 is the conductor per slot. So you will get 1020 armature conductors. Next, phi is given 7 milliweber. That is 7 into 10 to the power minus 3 Weber. So you can write in simple way 7 upon 1000 for easy calculation. Next, n is the speed in RPM equal to 1500. N is the speed, that is 1500 RPM. So we have to calculate generated EMF Eg. So the formula is Eg equal to phi Zn upon 60 into P upon A. Is equal to phi Zn P upon 60, phi Zn upon 60 into P upon A. So due to P and A, number of pole and number of parallel path are equal. That's why I'm cancelling P and A. So the remaining is phi Zn upon 60. You can directly, when lab connected generator is given, in that time you can directly put phi Zn upon 60 in formula. So phi is 7 into 10 to the power minus 3, or 7 upon 1000. 7 upon 1000. So 7, 1000 is in the denominator. Number of armature conductor Z equal to 1020, and the speed is 1500 divided by, this is 1000 into 60. Now after calculating this term, we we will get 178.5 volt. This is the answer. This is the answer. Very simple. First of all, you have to write the data. Whatever the data is given in the question, you have to write. Then what to find, right? Then what are the formula associated with the problem, you can write. After that, you will solve easily. Then you will get answer. Question number 10. A DC generator delivers a 30 ampere current to a load at 120 volt by consuming 4500 joule per second of mechanical energy. Determine the efficiency of the generator. Option A 75% efficiency, option B 85%, option C 80%, and option D 90%. Which one of the following option is correct? The correct answer is option C 80%. How I calculate, how I got the answer 80%? Let's explain. The data is given: load current equal to 30 ampere, load voltage is 120 volt, mechanical power is 4500 joule per second, that is equal to 4500 watt. Joule per second is watt. Okay. Efficiency is given. Um, the question is asking what is the efficiency. Efficiency means output upon input. Here output is the electrical power and input is the mechanical power. So mechanical power output is given as 4500 joule per second, but and efficiency is not given. We have to calculate efficiency and electrical power. So electrical power, how to find electrical power? First of all, put the formula. The formula for electrical power is the product of voltage into voltage and current. So B multiplied into I. B is given 120 volt and I is given 30 ampere. Now multiplied 120 into 30, you will get 3600 watt. Then efficiency equal to electrical power upon mechanical power into 100. So electrical power is 3600 upon 4500. We will get double zero cancel out, and you will get 0.8. After multiplying 100 into 0.8, you will get 80%. The correct answer is 80%. This is all about for the today's session of DC generator multiple choice question or DC generator previous year question. Next we will discuss DC motor MCQ at the in the next class. Thank you. If you have not joined our channel, then subscribe our channel. And if you are wishing to join our WhatsApp group for class related information or exam related information, then give, in the description you will get a link to join. If you are starting your if you are preparing for from zero, if you are starting your preparation, then you can join our Power Activity 2.0 for consistent preparation approach. Thank you.